Now the system's rebooting, and we'll just ensure that the CD-ROM is not in so it doesn't boot from the CD-ROM, and we should have a menu momentarily for booting the system. So the files have been copied, the important files at least. We'll just wait for the hard drive to be detected, and we should be up momentarily. We should see the grub menu. And there's the default grub menu. And this menu defaults to 640 by 480. And it will default to booting the Solaris OS. And the default boot process will load up the SMF, Service Management Framework, and we should have Solaris up and running momentarily. The reboot's all quick, and the installation of the files in this case required only the first CD. We were not prompted for the additional CDs, so it copied very quickly, and the system should be up momentarily. Here we see the SMF service descriptions. SMF is a new framework for loading services or scripts, run scripts, within a Solaris framework. It allows for parallelization, which means that multiple scripts can be run at the same time if there are no dependencies, and it also allows for the definition of dependencies and for service restarts in the event of failure, and so on. Once we go through this SMF section, then we will have a console login, either graphical or text-based. So it should be up momentarily. So again, installing Solaris using the text-based console installation is pretty straightforward, pretty easy to do, pretty clear, not a big deal whatsoever. But again, depending on your environment, you may or may not have additional requirements. Now, we didn't specify additional software such as the open source software that's included with Solaris 10, which would have taken a much longer time, obviously. Many of the packages, including Samba, MySQL, the editors such as Joe, Emacs, etc., were all skipped for the sole purpose of getting the operating system up and running. So we should be up momentarily. Notice the release in the upper left-hand corner says it's release 5.10. In other words, major SunOS version 5, but marketing version Solaris 10. The host name echoes properly UnixCBT Sun 1. It's FQDN, or fully qualified, and SMF is almost complete with its work. Now, unlike Linux, multiple consoles are not available during the boot up of the services or the load of the runtime scripts. And once a console is up and running, multiple consoles are not in the background available by default. It can be configured to be available. So TTY-mon can be configured to provide login services via various consoles accessible via Control-Alt F1 through whatever you program, but the default environment doesn't allow for it. The default environment provides one console, unlike Linux, where you typically have 6 consoles that are accessible via Control-Alt F1 through F6, with the X windowing environment configured to be on Control-Alt F7, or accessible via Control-Alt F7, executing those keystrokes, of course. Super. So disk 1 copied what was necessary, and the system rebooted. Once it rebooted, we're now in this state of loading the different services. The initial boot up is usually slow, and if your system is a server class system running many services, the boot up may be slow, but generally speaking, the boot up of Solaris 10 is much, much faster than prior versions of the operating system because of the SMF framework, but the initial boot up is usually slow, or the boot up subsequent to installation is usually slow, but for everything else it should be pretty quick. Unless, of course, you are running multiple services, many services with many dependencies, then it'll cause a situation similar to what we're experiencing here. So again, Solaris 10 x86 is a powerful OS. It is rivaling the offerings of the various Linux distros with the Solaris reliability on the line, and it's an appealing option for systems administrators in corporate environments because you know that you can get the support from Sun Microsystems. And you also know that Solaris has a reputation for being hard to break or being very, very reliable, which can be reassuring for administrators who are usually pressed for time and spread very thinly across many, many resources, computing resources. Super. SMF is almost done. We'll be talking about how SMF works, how it invokes init, how init invokes it, that is, and how all the different processes run. UFS is loading up the file systems, and logging is running. Notice the key pairs for RSA and DSA are being created, similar to Linux installs. This is for SSH support. That's what you're seeing here, so that the host has unique public and private keys for both RSA and DSA algorithms and can communicate using SSH. Now we see the KDM, or Keyboard Display Mouse Configuration software. This software allows us to configure the graphical environment. When you install in the console-based mode, this particular screen comes up after the installation. So we will select x.org or xsun. Either or will work. Either server will work. We can go at xorg or the Sun Microsystems server. And F2 to continue. And here we're prompted. It says it's configured with version 4, which uses domain name. That's automatically derived from the system's name. Do you want to override the default? And we'll just go ahead with the default of no. And here's a console. Let's go ahead and specify the password. And providing we provide the proper password, we'll be able to log in. Let's try it again. And now we're logged into the system. And what you see here is a configuration mismatch. In fact, we intended to select the xsun server, but these are the correct settings, ATI, and we'll change resolution from 1280. Let's make a change here. So it did detect the graphics card and the monitor, that it's a 17-inch monitor, but we do want to change the video device monitor, so we'll spacebar and go ahead with F2 to make the change. We'll stick with the driver for the ATI video card because it is an ATI Rage-based card. The monitor is okay, but we do want to change the resolution. The 17-inch is fine, it is 17 inches, but let's change the resolution to 800 by 600, and we'll increase the number of colors from 256 to the next highest offering, which should be 16 bits or 800 or 65,536 colors at 800 by 600 at 75 hertz. So let's go ahead. We'll F2, and we can test and save, which will alter the screen resolution. Let's F2 to continue. F2 once more to test. And now here's our test screen. We'll need to navigate with the mouse to indicate that this particular display is perfect. Super. So we've configured the graphics card, which means we should be able to make use of the graphical environment. Now, additional software that needs to be installed from the additional CDs, in this case CD2 is required, so we'll go ahead and specify that it's in the CD-ROM drive, which is option 1, which is the default. Remember, we selected the entire distribution, which is 4.5 gigs, so by no means are we complete, or have we completed the installation. However, do notice that the text-based installer allows us to specify an NFS, or network file system location, for accessing the files that are usually found on CD number 2. So you can mix and match where the files are located for the sake of completing the installation. The installer doesn't care. Let's insert it. Try it again. And this should read the disk. Now it's reading Solaris 10 software 2 for x86, and we'll copy the files that are important to support the entire distribution. Again, entire distribution means compilers and all sorts of programs that come with Solaris, but many of the open source programs are not installed by default with the entire distribution. Some are, most aren't. The most that are not are located on the software companion disk, which we can install at a later time. So this is going to go through its process, which takes a little while, but momentarily we'll have the configuration. So to recap, we've installed Solaris 10 at least up until this point. After the first round, the system, or the first disk, the system rebooted and created its RSA and DSA SSH-based public and private keys. It also prompted us for configuring the X environment. It also, while prompting us for graphical installation, presented us with two options. One was to use the X Sun server, that's Sun's X Windows server, or the x.org server, which is the open source version, which supports many of the x86 cards. In fact, it supports more of the x86 cards and monitors, including CRTs and flat panels, than the Sun Microsystems X server. So depending on the hardware that you're using, you may want to use the x.org server, which we used, but in our case we're using commodity hardware from Dell, which is supported by both Dell and by both Sun and x.org's implementation of X Windows. So we could have gone either way. We would not have had a problem installing X Windows and providing graphical support. At this stage, CD2 is installing its packages, so we'll have to wait this out. And when we return, we'll be at the stage where we'll have just a few more options than the console.